and function notation. We have looked at domain, range, increasing, decreasing, and extrema. And now we will talk a little bit about function notation, evaluating a function, and finding the difference quotient. So the function notation y equals f of x represents an equation that produces a value for y for a given value of x. Now this means that you cannot write f of x equals plus or minus the square root of x, something like that. This is not a function. A function must produce only one value for a given x, and this equation produces two values when x is equal to 9, for example. So once you see f of x equals something, you see the function notation, that automatically implies that this is the equation of a function. When we have the equation of a function, we can evaluate it at a specific value by replacing the variable with its value. So wherever we see x in the equation of the function, we can replace it with a 3. Now, every time we do that, it has to be in a parenthesis, especially important when x is a negative value, when the value of x is negative. So this will be negative 3 squared is 9, plus 2 times 3 is 6 minus 5. So that is negative 8. In this example, to find g of 20, this is the square root of 2, 20 plus 5. So this is 2 times 20 is 40. That's the square root of 45. And if they are asking us to simplify it, 45 is 9 times 5. The square root of 9 is 3. 3 square root of 5 will be the exact answer. We don't want to evaluate the irrational value of square root of 5 in our calculator. That will give us some decimal approximation. If we want to find here h of negative 1, we will plug in negative 1 for x. In the bottom, negative 1 squared minus negative 1 minus 2. Negative 1 minus 1 is negative 2 in the numerator. Negative 1 squared is positive 1, plus 1 minus 2. I have negative 2 divided by 0. This is an undefined operation in mathematics. We cannot divide by 0. And actually, if we had found the domain of h, the value of x equal to negative 1 would not be part of the domain. And the reason x cannot be part of the domain is that the value h of negative 1 does not exist. Now, we can evaluate a function from the graph. F of negative 1 means when x is equal to negative 1, what is the y? So when x is negative 1 here, and I go on my graph and I look down, the point on the graph is this point, and the y for that point is equal to negative 2, which is the y of the point negative 1, negative 2. Now, backwards, if they tell you what the y is, f of x is 3 means that the y is equal to 3. So if they tell us that the y is equal to 3, and I look on the graph of on what point that might be, they are asking us what is the x, and the x is equal to 3. So they are asking us x of the point that has negative 3 as a y, right? If I graph the function absolute of x minus 3, when x is equal to 0, 0 minus 3 is here. When x is 1, 1 minus 3. When x is 2, 2 minus 3. When x is 3, 3 minus 3. 4 minus 3. 5 minus 3. When x is -1, it's again 1 minus 3. When x is -2, it's 2 minus 3. When x is -3, 3 minus 3, etc., etc. The graph of the absolute function looks like that. So it says find f of -4. When x is -4, the point that I have here is the point -4 comma something. That's the question they are asking me. And that y was 1. When f of x equal to 0 means that y is equal to 0 and y is equal to 0 on the x-axis. And I had a question mark for the x and a 0 for a y, and a question mark here for the x and a 0 for the y. And the question is, what are these x's? And there are two x's, x equals -3 or x equal to +3. This is not a one-to-one function. The value of y equal to 0 did not come from only one x. Now, in addition to evaluating a function for a particular value, it is possible to evaluate the function for an expression. To do that, we substitute the expression in the place of the variable in the equation of the function, and we have to use parentheses, and then we follow order of operations. So p of n minus 3 here will equal to, instead of n squared, n minus 3 squared, instead of -2n, -2n minus 3, n plus 5 doesn't have a variable. Order of operations says first I have to do the exponent. So I'm going to do this expression first, n minus 3 squared. And to shorten my process here, I'm going to use for my packet the square of a binomial. It's going to be a squared minus 2ab plus b squared. So that's going to be n squared minus 2n times 3. So 6n plus b squared, which is 9, minus 2n minus 3 plus 5. And the next thing I'm going to do is the distribution. There is a 1 here, and there is a -2 in front of the second parenthesis. So when I distribute n squared minus 6n plus 9, minus 2n plus 6 plus 5. And the last thing I'm going to do is I'm going to add like terms. So my final answer, n squared, -6n minus 2n is -8n. 9 and 6 and 5 is 20. So that's my answer. For f of x equals the square root of 2x plus 3x, I'm going to replace x with 8x squared. So it is the square root of 2, 8x squared plus 3, 8x squared. And that is the square root of 16x squared plus outside of the root 24x squared. The square root of 16x squared is the square root of 16 times the square root of x squared, which is 4 times the absolute of x. I want to make sure that x, the answer is not a negative, if in case x is negative, plus 24x squared. One of the very important things about a function is the slope between 2 points. And the slope between 2 points is given by what we call the difference quotient of f at a given x. So when my 1x value is x with f of x, at the 1x value, I have a point x with f of x. And then I move a little bit further away. So my other x value, in my other x value, I have, say, x plus h. A little bit I moved away from x. I will have a y corresponding to that. The slope is x2 minus x1 in the denominator, y2 minus y1 in the numerator. The difference quotient is y2 minus y1, so f of x plus h minus f of x, and in the bottom x2 minus x1, but x plus h minus x will give me h. So this is called the difference quotient. It is a very important topic in calculus, and it describes the slope of a line connecting 2 points on the graph of f. Any terms with no h in the numerator will cancel once you evaluate correctly the difference quotient. Then h will always be able to divide whatever is left in the numerator. And therefore h will always simplify. Let's do some examples. If f of x is 2x plus 5, in the numerator I need to know f of x plus h. That will be 2x plus h. Remember, when you are substituting x with x plus h, you have to use parentheses, minus 5. So you want to distribute 2x plus 2h minus 5. And then you want to write the expression of the numerator, which is f of x plus h minus f of x. Every time you substitute in algebra, you have to remember to use parentheses, divided by h. The next thing to do is to distribute. I have a 1 in the first parenthesis and I have a negative 1 in the second parenthesis. So when I distribute, I have 2x plus 2h minus 5 minus 2x plus 5 divided by h. If I have done a good job, anything that doesn't have h will simplify. So I will have 2x minus 2x and negative 5 plus 5. So I'm going to end up with only 2h in the top over 2 over h, and the h's will cross off because h can divide 2h. So the difference quotient for this function is equal to 2. For the next function, it's a little more involved. F of x plus h, let me actually use a different color. So f of x plus h will be, if I substitute x plus h squared minus 3x plus h plus 4. I recommend that you pause the video here so that you can do the evaluation yourself and then check and see if you got it correctly. If you remember, we have to do the exponent first. So I have to do a squared plus 2ab plus b squared and then I have to distribute. So I'm going to write the numerator all together after I distribute it. So when I distribute, my numerator has f of x plus h in the front. So it will be x squared plus 2xh plus h squared minus 3x minus 3h plus 4. And then I will subtract f of x, which is x squared minus 3x plus 4. Remember to always substitute the quantities in parentheses. And in the bottom, I have to divide by h. So I'm going to distribute. The first parenthesis has a 1. The second parenthesis has a negative 1. So when I distribute, I will have x squared plus 2xh plus h squared minus 3x minus 3h plus 4. And when I distribute the negative 1, negative x squared plus 3x minus 4. In the bottom, I have h. If I have done a good job, anything that does not have h will actually cancel. So this x squared that is positive will cancel with this x squared that is negative. This negative 3x will cancel with this positive 3x. And this positive 4 will cancel with a negative 4. And I will end up with 2xh plus h squared minus 3h divided by h. When a monomial divides a polynomial, it divides every term of the polynomial separately. So 2xh divided by h plus h squared divided by h minus 3h divided by h. And these h's will go, one of those h's will go, this h and that h will go. I will end up with my final answer, 2x plus h minus 3. This concludes our original review for functions, which was functions and function notation.